Hello everyone, we are group 2 of division O and in this video we are going to explain about IO modules. Let's begin. So computer architecture is the conceptual design and fundamental operational structure of a computer system. It describes how a computer software and hardware components interact to perform computer's tasks, including the data flow and memory. It also includes the design and organization of the instruction set, memory, and input output system of a computer. It is the foundation upon which the design of computer system is built. So from this we can conclude that computer architecture is nothing but combination of set of instruction and computer organization. Now input and output module. IO module stands for input output module, which is a device that acts as the connective bridge between computer system at one end and IO or peripheral device of some kind at the other, such as printer, webcam or scanner.
The computer system's input-output architecture is its interface to the outside world. Till now, we have discussed the two important modules of the computer system, the processor and the memory module. The third key component of the computer system is the set of input-output module. Each input-output module interfaces to the system bus and controls one or more peripheral devices. There are several reasons why an input-output device and peripheral devices are not directly connected to system bus. Some of them are as follows. There are a wide variety of peripherals with various methods of operation. It would be impractical to include the necessary logic within the processor to control the various devices. Also, the data transfer rate of peripheral is often much slower than that of the memory of the processor. Thus, it is impractical to use the high-speed system bus to communicate directly with the peripherals. And also, peripherals often use different data formats and word lengths than that of the computer to which they are attached. Thus, an input-output module is required to act as a connecting bridge between the computer system and the peripheral devices. And now let's discuss about system bus. A system bus is a single computer bus that connects the major components of a computer system. It combines the function of data bus to carry the information, an address bus to determine where it should be sent, and a data bus to determine its operation. And peripheral devices are devices that are connected to the computer but is not a part of the computer's architecture. Peripheral devices can be of both internal and external type. Example of peripheral devices can be mouse, keyboard, monitor, printer, hard disk, and etc. And now my friend Rohan will explain about the external device interface.
An external device interface in an input-output system is a mechanism that allows a computer or other device to communicate with and control external devices. The interface typically includes several components such as control module, status signal, and data signal. Control module. This is the part of the interface that manages the communication between the computer and the external device. It may include hardware such as microcontroller or field programmable gate array, or software such as a device driver. Status signal. This is a signal that is sent from an external device to the computer to indicate the device current state, such as whether it is ready to receive commands or if it is currently in an error state. Data signal. This is a signal that is used to transfer data between the computer and the external device. The data signal may be in the form of electrical signal, optical signal, or a combination of both. Further, the transducer converts data from electrical to other form of energy during output and from other forms to electrical during input. So next slide. So as in the diagram, you can see that there is a control module, status signal, and data signal. You can see that how it communicates with an external device. Further, the signal from input output device gets converted by transducer and sent to the user.
Input output techniques. There are three principal input output techniques. First one, interrupt input output. An interrupt input output is the process of data transfer in which an external device or a peripheral informs the CPU that it is ready for communication and requests the attention of the CPU. Second one, DMA techniques, direct memory access. Direct memory access is the data transfer strategy that bypass the CPU, instead the using dedicated DMA controller to transfer data between memory and the device. Last one, program input output. Program input output is the method of data transmission via input output between central processing unit CPU and peripheral device such as parallel ATA. storage device. Each data item transferred initially by the instruction in the program involving the CPU for every transaction. In contrast, in direct memory access process, the CPU is uninvolved in the data transfer.
In the previous slide, we have seen about the program of input output. In this slide, we will see about the input output commands. There are four types of command. Control command. The control command is used to activate the peripheral and tells it what to do. The second is a test command. This command is used to test various status conditions associated with the input output module. The third is the read command. It is used to obtain an item of data to the peripheral and place it in an internal buffer. Fourth is the write command. It is used to take an item of data from the data bus and transmit that data item to the peripheral. In this slide, we will see the interrupt driven of input output. A better protocol is to have the input output and computer device work independently. Input output modules, when ready, sends an interrupt to the computer. When the current situation completes, the computer interrupts the current program and saves the current status and goes to an interrupt service. In this slide, we will see how the interrupt driven input output works. Input outputs when sends interrupt to the CPU issues read command. Input output module get data from the peripheral while the CPU does other work. When the work is done, input output then sends interrupt to the CPU. So after that, CPU requests the data from the input output devices, and input output module then sends the data to the CPU.
Myself Rushikesh Patil, and I will be speaking about DMA and input output problems. So speaking about DMA, we have CPU, input output and memory. Whenever we have to access memory, first input output goes to CPU, then CPU to memory, which requires 2 cycles and basically takes more time. There is direct connection between input output and memory, and this connection is controlled by DMA. DMA has the independence to access the main system memory of central unit processing unit, which is known as CPU. Without DMA, the CPU is using programmed input output, so the operations which are carried out are fully busy and unable to perform the other work. And with DMA, the CPU first begins the transfer and then it does the other operations while the transfer is in progress. Now further speaking about input-output problems, it is slower than CPU and RAM. It needs input-output modules. For a variety of peripherals, it may show different amount of data, speed and formats. Whole system must have to be efficient to receive input and show output.